This is section 7-2, reading a floor plan. The objectives of this lesson are to compute the perimeter and the area of a polygon, to compute areas of irregular regions, and to compute volumes of rectangular solids. These are some of the key terms that will be discussed during this unit. Floor plan, scale, area, congruent, apothem, perimeter, the Monte Carlo method, volume, and British thermal units. So you might ask yourself, how much space do I want? How much space do I need? What type of apartment would you like when you first move out on your own? A lot of times you're going to have floor plans before you even see the apartment, and you're going to have to see what the dimensions are and whether that space is sufficient. And how can houses that have the same floor plan on the inside look different from each other on the outside? So there's differences in how buildings appear on the outside as opposed to the actual floor plan and how everything is divided up inside. So let's look at example 1. Jerry is using the floor plans for his new home to help him purchase base molding for the place where the walls meet the floor. The plans are drawn using a scale of 1/4 inch represents 1 foot. He measures the walls on the floor plan with a ruler and finds that they total 23.5 inches. If molding costs $2.10 per foot, how much will Jerry spend on molding? So let's first look at the scale on the floor plan as opposed to what it actually is. And you'll notice it's 1/4 inch represents 1 foot, okay? So if we take and look at that and say, okay, we have a 1/4 inch per 1 foot, the number of inches on the floor plan equals the number of feet in the room, okay? So we can set up a proportion just like this to find out what the measurement on the floor plan is equal to in the actual room dimensions. So actually plugging in numbers, you can see we have 0.25 over 1 is equal to 23.5 over x. The 23.5 is what we saw in the problem. That's the 23.5 inches on the floor plan. Well, how many feet is that actually in the room? So if we solve our proportion, we get that x is simply equal to 94 feet of molding, okay? So now we know how much molding he has. We can now figure out how much it's going to cost. So we multiply the 94 feet by $2.10 per foot, which was the cost, and we come out with $197.40. So that's how much molding he's going to need and how much it's going to cost. All right, so let's look at another example. Gabriella plans to carpet her living room except for the 1/4 circle shown in the corner. That area will be a wood floor where she will put her piano. The radius of the 1/4 circle is 8 feet. If carpeting costs $9.55 per square foot, what is the cost of the carpeting she will use in her living room? So let's look at the formula for the area. The area that she will need is simply length times width, okay? That's this dimension times this dimension minus this 1/4 circle over here, so that's minus pi r squared over 4. So pi r squared would be the area of a circle, but this is a 1/4 circle. That's the reason we have the 4 here. So the area she's looking for is length times width minus pi r squared over 4. Now, if we plug in numbers, we know the living room dimensions are 25 by 16, and we know that the 1/4 circle has a radius of 8 feet. We plug in those numbers and we come out with approximately 349.76 square feet of carpeting she will require. Now, if we multiply that, approximate to 350 square feet for carpeting times 955, we come out with that she's going to need $3,342.50 worth of carpeting. All right, example 3. Delgado's landscape design is building a large gazebo for a backyard. It is in the shape of a regular octagon. That means each of the sides is equal, sort of like a square where each of the sides is equal. The only difference is this is an octagon, so it's got 8 sides, but they're all equal. Each side of the gazebo is 10 feet. They need to purchase wood for the floor. It costs $14 per square foot for a special type of wood. Find the cost of the gazebo's floor. Well, the formula for the area of a regular octagon is equal to 1/2 the apothem times the perimeter. The apothem is simply this dimension right here, as you can see. The perimeter we can get from the side. Each side is 10 feet, so the perimeter is going to be 10 times the number of sides, which is 8. So the area is 1/2 the apothem times the perimeter. And this simply comes out to be 1/2. The apothem is 12. The perimeter is 80. 1/2 12 times 80, or 480 square feet, is the area of the octagon. And again, since we're trying to find the cost, we know it costs $14 per square foot. So we say the area, which is 480 times 14, comes out to be $6,720 for the floor. Okay, now example 4. Don sculpts out a region for a flower garden as shown. He takes a digital picture of the garden. The irregular region, which would fit inside a rectangle that is 15 yards by 20 yards. He superimposes a 15 by 20 grid over the photo on his computer. The area of the garden impacts the cost of mulch, plants, fertilizer, and so on. What is the area of the garden? Okay, so we got a very irregularly shaped area that we need to find. Well, if we use this proportion where we have points inside the region divided by the total random number of points in the rectangle is equal to the area of the region over the area of the rectangle. So we can use this proportion to get an approximation for the area. All right, so we come out with 631 points are inside the irregular shape. 1,000 points are in the rectangle, and that is equal to the area of the irregular shape, which is x, divided by the area of the rectangle, which is simply 15 by 20, or 300. And if we solve that for x, we come out with about 189.3, and that is the area of the irregular shaped garden. And this is often referred to as the Monte Carlo method of approximating the area of an irregular shape. All right, now example 5. We want to find the volume of a room that is 14 feet by 16 feet with an 8-foot ceiling. Well, the volume is simply equal to the length times the width times the height, okay? Well, from up here, we got that the length and width are 14, 16, and the height is 8. So if we plug those in, we end up with the volume is equal to 1,792 cubic feet. All right, example 6. Mike's bedroom measures 16 by 14 and has a 9-foot ceiling. It is well insulated on the west side of his house. How large of an air conditioner should he purchase? All right, this is an interesting problem. Okay, we have a formula here which can calculate the approximate BTU ratings. BTU rating is equal to while over 60. Well, what is while equal to? While is simply an acronym for width, height, insulation, where good is 10, poor is 18, length, and E for exposure. If it's a northern exposure, it's 16, east 17, south 18, and west 20. If we plug those numbers into our formula and calculate, we come out with the BTU rating of approximately 6,720 BTUs, and that will be the size of the air conditioner you will need for this bedroom based on the measurements given.